Hi guys, this is another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you're looking for elsewhere. There's a lot of information out there. Be aware that I'm not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today, we're going to be going over lesson 4.1, Comparing Two Quantities. More specifically, we're going to be discussing ratios. All right, we have two vocab terms to go over. The first being ratio. A ratio is a comparison of two or more numbers or quantities. So a comparison of two or more numbers or quantities. Another golden rule, order matters when it comes to ratios. You can't write your answers or your ratios in any order you want. So order matters. All right, our next vocab term is term, or term of a ratio. Term of a ratio means or is referring to the numbers or quantities, that means an amount of something, that are being compared. So the numbers or quantities that are being compared. And I'll go over that in a little bit. All right, so we're just going to start talking about ratios, and then we're going to get into how to write them. So first, let's look at this story. It says you can compare numbers or quantities by comparing sizes. So let's suppose there are 7 bags of orange cubes and 4 bags of green cubes. Each bag has an equal number of cubes, and we have no idea how many are in there. Could be 1 each, 2 each, 5 each, who knows. We're going to write a ratio comparing the two. So it's going to be a lot of writing right here. So the ratio of now we are comparing 2 or more numbers. So I'm going to compare this as such. I want the ratio of the number of bags with orange cubes to the number of bags with green cubes So the ratio of the number of bags with orange cubes to the number of bags with green cubes is, well, this is how you write a ratio, or the most common way. So like we said, order matters. So the first thing that I see is ratio of number of bags with orange cubes. So number of bags with orange cubes, 1, 2, 3, 4, 5, 6, 7. So I write 7 first. And then we write the word, or not word, colon. That represents your word 2. So this is 7, 2. Well, the next, I want number of bags with green cubes. 1, 2, 3, 4. So the ratio of number of bags with orange cubes to number of bags with green cubes is 7, 2, 4. And that's your answer. That's a basic ratio. We are comparing bags with orange cubes to bags with green cubes in that order. If I wanted to switch it, then you'd switch your answer. All right, 2 things to keep in mind. The first one, it's kind of hard to understand until we get a couple lessons in. 7 to 4. This does not mean or this does not give the actual number of cubes. So 7 to 4 does not mean there's actually 7 cubes that are orange and 4 cubes. Ratios don't really give you specific, precise amounts. Kind of like if I said a unicorn, that doesn't exist, ate half of my pizza. One half doesn't really tell you how much pizza they ate. So that's what a ratio is. And fractions are actually ratios. So these numbers don't give us specifics. So what does it mean? It just means for every 7 orange bags, there are 4 green bags. Meaning, if I have more orange bags, I'm going to have more green bags. So I could double and say, oh, there are 7 orange bags, or 7 bags with orange cubes, technically. If I doubled that to 14, I would double that to 8. So these aren't really specific amounts. So think of ratios as fractions, and fractions actually are ratios. So fractions don't really give you specific amounts. All right, continuing. When you have two quantities, such as the lengths of 2 rods, and they have the same units, you can write ratios without units to compare the quantities. Yay, we don't have to write labels. That's nice, right? All right, so I'm going to make up 2 different problems. So, well, it says you can write a ratio unit to compare the quantities. We're going to write 2 different ratios. The first ratio problem that I'm going to come up with, I want the ratio of the length of the red rod to the blue rod and that is order matters. So ratio of length of red rod to blue rod. So red to blue in that order. So red, 1, 2, 3, 4, 5. It's even got it right there, 5 centimeters. Again, because they both have centimeters and they're identical. You don't need to write labels. So write your colon. That's the word 2. And then blue rod comes next. That would be 9 centimeters. So 9. So the ratio of the length of red rod to blue rod, red to blue, in that order is 5 to 9. And that's pretty much it. We compared the length of both in a specific order. All right, let's do one more. Let's do the ratio of, let's mix it up, the length of the blue to red. I know, I really mixed it up, right? So the length of blue to red, in that order. So blue, 9. Red, 5. So our ratio on this one, our answer is 9 to 5. And again, that's it. So here are 2 different ratios to compare the same thing. Do these mean the same thing? Absolutely not. This is red to blue in that order. This is blue to red in that order. They don't mean the same thing. All right, let's continue. So as I discussed, you cannot compare 2 quantities using a ratio if they can't be expressed with the same units. So let's look back at that real quick. Because the labels are the same, we can express it as a ratio. You can't if they don't match. So let's make a note of that. The measurements, or the measurement, must be the same. The measurement must be the same. What does that mean? That means, do they measure the same thing? So, do they both measure distance? Do they both measure volume? Do they both measure mass? If they do, then they can be expressed as a ratio. But make sure the measurements are the same. So let's do an example to explain what I'm talking about. Number 3, can the following be expressed as a ratio? If yes, you're going to have to prove it. So we have 7 centimeters and 3 meters. So first, do they measure the same thing? Absolutely. They both measure length. However, do they look the same? No. That's a bad thing. You know what that means? It means you must change the units to match before writing a ratio. Now, how do you know which one to change? Should we change 7 centimeters to meters or 3 meters to centimeters? Well, all you need to do is change the one in which the decimal moves right. Change the one in which the decimal moves right. The larger unit, basically. Technically, we haven't done any work, so this is not technically work, so it's not like this is a super long problem. All right, so let's write out our little scale. So King Henry died unusually, which means meter, liter, or gram. Drinking chocolate milk. So kilo, hecto, deca, meter, liter, or gram, deci, centi, milli. All right, so I want to move the one in which the decimal will go to the right, or the larger unit. So centimeters larger, or is meters larger? Well, kilo means 1,000. That's the largest. Centimeters is over here. That's the smallest over here. So that means I want to change. Let's see, meters is right there. Centimeters is right there. Which one's on the larger side? This one, meters. So that means I'm going to change 3 meters. You know what that means? It means the decimal is going to move right. If it's not moving right, you done messed up. You need to choose the other one. All right, so 3 meters. Write your number, find your decimal, right there. To go from meters, right there, that's milli. So meters to centimeters, once, twice to the right. So once, twice to the right. You absolutely have to show this work. I doubt your teacher would be happy if you didn't, and probably not give you any credit. That'd be very sad. All right, so 3 meters is 300 centimeters. All right, 7 centimeters is already centimeters, so bring it on down. All right, do they match? Absolutely. You know what this means? Our ratio is 7 to 300. So, can the following be expressed as a ratio? We actually didn't answer the question yet. The answer is yes. Why? Because they both measure length, and we have proved it. We actually found the actual ratio. All right, let's do the next one. 3 pounds and 5 feet. Do they measure the same thing? Absolutely not. This measures weight. This measures feet. Yeah, no. So, can they be expressed as a ratio? Absolutely not. We are going to briefly explain why. Because feet measures distance and pounds measures weight. Not mass, weight. It's pounds. So you cannot convert pounds to feet and feet to pounds. That would be kind of weird. So no, you can't compare them. Sorry. All right. Next example. We are to write 2 ratios to compare 4 nails. So 2 ratios to compare 4 nails and 1 piece of wood. So some more writing. Let's do the ratio of number of nails to number of pieces of wood. All right, now I have not used this strategy yet, but if you get a little lost in your order, because order matters, think about what you're doing, in what order you need it. So number of nails to number of pieces of wood. So nails to wood, nails to wood. So this is what I'm going to do to keep track. N to W. It means I need nails first, wood second. And as long as I keep that, I won't mess up. So nails, 4. Colon. All right, wood, 1. So nails to wood, 4 to 1, in that order. So that's one ratio. It said write 2 ratios to compare them. So let's basically flip it around. Let's do the ratio of number of pieces of wood to number of nails. And nails does not have an M. All right, so I want number of pieces of wood to nails. Wood to nails. So W to N. Wood to nails. All right, wood, 1. Nails, 4. So our ratio is 1 to 4. So here are 2 ratios that we can use to compare 4 nails and 1 piece of wood. 4 to 1 and 1 to 4. All right, now what does this mean? Again, like we mentioned on the front page, ratios do not give the actual number of something. So this does not mean you have 4 nails and 1 piece of wood, or 1 piece of wood and 4 nails. Like, what are you going to build with that? Like, nothing. So what does this mean? The second one, I think, makes a little bit more sense. It basically means when you have 1 piece or 1 board, you need 4 nails to nail it down to something. So if I doubled it, let's say I have 2 boards, I'm going to need 8 nails. So basically, every time you have 1 board, you got to have 4 nails to go with it. So it doesn't mean you just have 1 board and 4 nails. So if I have 2 pieces of wood, you need 8 nails. If I have 3 pieces of wood, I need 12 nails. So these aren't actual real numbers. It's just a baseline. Now, one other thing. 1 to 4 and 4 to 1. If I said, are these the same? Well, do they look the same? Absolutely not. 1 is first, 4 is first. Remember, order matters. So these are not equal, not the same. I mean, clearly, they don't even look the same, so they're not the same. So don't forget, order matters. All right, one other thing to think about. We can write these as fractions. We'll get to that a little bit later. So let's say I had 1 to 4 as 1/4, and I had 4 to 1 as 4 over 1. If I have 1/4 of a cookie and someone has 4 cookies, that's obviously not the same. And the person with, well, 1/4 of a cookie is very sad because someone ate 3/4 of it. Either that or it was them and they just forgot. So again, order matters. They're not the same. All right, let's continue. There were 55 adults and 32 children at a party. Yay. All right, A, find the ratio of number of adults to number of children. Technically, we don't need this, but I just want to visualize it. So let's draw this little bar model. All right, 55 adults, 32 children. So basically more adults. So let's say these are our adults, 55 of them. They're excited to be there. All right, 32 children, so fewer. So they're over here. Okay, so we're just looking at this model to realize, oh, more adults than children. And we can see everything as a whole. All right, I want the ratio of adults to children. Adults to children. So I'm going to write my little reminders, adults to children, A to C basically. All right, so A, adult. There are 55 of them. Write that right there. 2, children, 32 of them. So that's right there. So adults to children, 55 to 32. That's it, you're done. Or finished, I should say. All right, let's do the next one. Find the ratio of number of children to total number of people. So let's look at our picture again. There are more adults than children. All right, so I want children to total. Children to total. So children to total. All right, children. there are 32. That must come first because order matters. All right, total. Oh, it doesn't give me the word total. So I'm going to have to show some work. I know, very sad. Not really. It's exciting to show work. So to find the total, we need to do 55 plus 32, basically all of them. 55 plus 32, let's see, 5, 6, 7, 5, 6, 7, 8. That would be 87. And that's your total. So 87 goes right here. So children 2 total in that order is 32 to 87. All right, let's continue. All right, 2 out of 3 animals in a pet store are birds. We're going to write the ratio of number of birds to number of animals using all 3 proper ways to write a ratio. Up until now, we've only been writing one way to write a ratio, the best way, in my opinion. All right, so let's draw a little model to show these animals. So 2 out of 3 animals are birds. So let's draw a little bar, split it into 3, and basically 2 out of every 3 are going to be birds. The rest, we have no idea what they are. Maybe they're dogs, maybe they're cats. Probably not a good mix. All right, I want the ratio of number of birds to number of animals. All right, you can write the ratio of birds to animals. Again, it says birds to animals. As, all right, birds to animals. Birds, 2, colon, or 2, 3. So that is actually our preferred answer. All right, there are 2 other ways. What's the next way? Well, if you haven't caught on by now, the way we read this is 2 to 3. So that's literally the other way to do it. 2, 2, 3. But why write 2 if you can write a colon? I mean, come on. Okay, next. I've mentioned this. Ratios can be written as fractions because fractions are ratios. So, first number on top. Second number on bottom. So 2 to 3. Now, we usually stick with this, but keep in mind, ratios can be written like this or this. Okay, let's make one little note about that fraction. 2/3. Because 3 represents the total number of animals and the top represents a part, this 2/3 right here means 2/3 of the animals are birds. Just a random FYI. Okay, next. Number 7. The birds in a pet store are parakeets and canaries. So yappy birds and yellowbirds. There are 3 parakeets and 7 canaries. Part A, find the ratio of parakeets to canaries. We're just going to draw one picture on this and be done. All right, parakeets and canaries. There are 3 parakeets, 7 canaries. That means there are 10 animals total. So let's split this into 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that looks horrible. Let me fix that. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, that's better. So 3 are parakeets. 1, 2, 3. So we've got some yappy birds and 7 canaries. So a bunch of yellowbirds. Okay, we're going to find the ratio of parakeets to canaries. Parakeets to canaries in that order. So parakeets to canaries. Parakeets, 3. Canaries, 7. So our answer is 3 to 7. And again, this is our preferred answer. All right, could you write it another way? Yes. So 3 to 7 could be written as 3 to 7 or 3 over 7. All right, now, one note about this fraction. This fraction, 3/7, does not tell you, what fraction of birds are canaries or parakeets. So 3/7 does not tell you what fraction of the birds are canaries or parakeets. Why? Because the 7 does not represent the total. So this is a part to a part. So parakeets to canaries, part of the animals to the other part. The other one up here, 2/3, or 2 to 3, the top one was a part, the bottom is a total. All right. Part B. Find the ratio of parakeets to total number of birds. So parakeets to total. Parakeets to total. So parakeets to total. Parakeets, 3. So we're going to use the information we used up there, or did up there. All right, total. Well, since we drew our picture, we can easily see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our answer is 3 to 10. And we're happy because we can go on to the next one. Find the ratio of canaries to total. Canaries to total. So canaries to total. In that order. So canaries, 7. The total, there's 10 birds total. So our ratio of canaries to the total is 7 to 10. If I were to write these as fractions, 3 out of 10, that does mean 3/10 of my birds are parakeets because the bottom number would be the total, and 7/10 of my birds would be canaries. Remember, these don't actually give you real numbers. It doesn't mean you really have 10 animals. I could have 20. Keep that in mind. All right, we've got one more example. Let's scroll down to this little note right here. Very important. If you ever have a question that says, what fraction of, or how many times, you're going to write a fraction. All right, so if you see the words what fraction of, or how many times, you'll write a fraction, and the very next item you see after those words, literally the next thing you see after those words, is going to be your denominator, and the other thing, wherever it may be, will be your numerator. So let's apply that up here to this problem. It says the height of a giraffe and the height of a horse are represented in this model. So this is a comparison model. Don't forget, these are called units. All right, so we notice that the height of the giraffe, 6 units. Height of the horse, 3 units. All right, part A. How many times? Oh, I see that phrase. When you see the phrase, what fraction of, or how many times, you write yourself a fraction. Pretty simple, right? All right. How many times the height of the horse is the height of the giraffe? So basically, this giraffe, how many times the horse is that? You'll notice that it's looks double, right? Okay. So when you see that word, you're going to write a fraction. The very next thing is your denominator. So how many times? Okay, the next thing I see is going to be our denominator. The height of the horse. Bam, that is your denominator, horse. And then you're going to change it to numbers, of course. All right. The second item is your numerator, wherever it may be. So that, well, it's right there, is the height of the giraffe. That's the other thing. So the giraffe is your numerator. Okay, now we're going to fill it in with our numbers. The giraffe, 6 units long. Horse, 3 units long. That's improper. So top divided by bottom, 6 divided by 3. 2. So how many times the height of the horse is the height of the giraffe? You're going to say, we start backwards. The height of the giraffe is 2 times the height of the horse. So this makes more sense after we have the answer. So we're basically saying the giraffe is 2 times as big as a horse. Would you all agree that it takes 2 of those? So the giraffe is twice as big, basically. All right, so that's one possible answer. What else could you write for an answer? You could simply write how many times the height of the horse is the height of the giraffe. It can be a little complicated, so 2 times would be acceptable to just write that. All right, last one. How many times? Oh, we see that phrase. So what do you do when you see that phrase? What fraction of or how many times? You write a fraction. All right, the very next item is going to be your denominator. So how many times? Okay, the very next thing we see is going to go right on the bottom. Height of giraffe. So put giraffe on the bottom. All right, next thing. Height of horse. That goes on top. All right, fill it in with numbers. Horse is 3 units. Giraffe is 6 units. It's proper, but 3 and 6 have common factors, so you got to simplify. Always and forever. It's never going to change. So divide by 3, divide by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So basically we're saying the horse is only half as big as the giraffe. So the horse is 1/2 times the height of the giraffe. So that's our answer. Always start at the back. So the height of the horse is 1/2 times the height of the giraffe. Also acceptable would be 1/2 times. All right, I hope this has helped with ratios and starting to get a little of an understanding about them and how to write them. If it didn't, I hope you can find what you're looking for elsewhere. Y'all have a great day.